We are back once again. It is LeetCode day 138. 38 days of me promising a video that still has not released. But this is a necessary evil. But you know what's not evil? The comments on the YouTube channel. We have a comment from Front End Fatigue, which is a pretty cool name, by the way. Shall I embark upon the LeetCode everyday journey knowing that it will be my demise? I thought the same. This will also be my demise. If so, I plan on documenting it like you. This would be fire. Because you are fire. True. That would be pretty cool. That would be pretty cool. I gotta be honest. That would be pretty epic. And then we have another comment from Your Dark Side. Hey, Manny, I came across your videos in the YouTube's recommended page. It's your time to shine. Feel strong, man. Secondly, when did you start learning how to code, and are you self-taught? Define learning how to code. The first time I pretty much in college, I took before college, I was actually going to choose architecture as a degree, but then I was in the degree choosing place and I was like, I'd like my major to be architecture, and they were like, we don't have that here. So I was just like, okay, I'll choose computers. So that's what I was doing. And then a little bit beforehand, I wanted to try and make a iOS iOS game. And that kind of ended up being my intro to programming. So I pretty much kind of learned how to make this simple iOS game using, I think it was Objective-C and SpriteKit. It was a disorienting mess, but it gave me a really good intro to programming. And then when I took my first programming course, it was a lot easier to understand just because I had already kind of suffered through Objective-C. Objective-C is a mess, by the way. Okay, they need to look at Objective-C, okay? Objective-C needs to be looked at. The syntax is ridiculous. But yeah, I would say then, so maybe a little bit before college. So at this point, I ended up doing like 4 years in school. But we mostly did C++ and no big apps or anything like that. And then, yeah, I would say yes. I would say, I feel like I feel like everyone who programs is sort of self-taught because there's always like the resources that there's always like a task that you're prompted with, and then there's like you do some calculations and you see like a delta or a difference between the skills you have and the skills you need to complete the task, and then you kind of have to just go and like find the information to make it make sense. But while I learned a lot in school, it does feel like I learned a lot of it outside of school because I was making like apps and like small nonsensical things that didn't make any sense. But the school definitely helped because it kind of forces you to like, you know, show up and like just kind of show up and stay consistent basically. So I would say sort of a mix. Yes. I did school and projects outside of it. Maybe both, not certain. But you know what I am certain about? I'm certain that LeetCode will be our demise, so I want to good luck to Front End Fatigue and check out the content. LeetCode will be our demise, but maybe it won't be because we've kind of been powering through the easy problems. I would say the way the schedule's changed, doing the easy problems has actually been a net W. So there's a couple problems you ran into where there was like great growth. So it's really interesting to see. It is really interesting to see. Yeah, something about the easy problems just works. There's like a small introductory problem to a difficult concept, and it's like it's pretty much like an atomic encounter, basically. It's kind of like if you were to fight I guess there's no better example than LeetCode itself. It feels like the mediums are a combination of a few of the other, maybe a couple of easies together. For example, there's a medium which is like a string problem, but it's mixed in with like a cheat code or an intuition from another easy problem about how you can simplify like grouping letters. But also you can layer shortest paths on top. So it's like two easy problems, two easy concepts make a medium. Maybe multiple medium concepts make it hard, which is why there's always such a reach. My only problem with doing the mediums before, though, it felt like I would ingest a lot of information for one thing, which was sort of portable, but the next problem would be something completely different. It's like I do like topo sort for one problem, and then you go and now you're doing like a BFS, which is sort of related. I guess it is related, but it's just, I don't know. There's a way, I guess the features of the problem, I'm tuning myself to the features of the problem just didn't seem as linear. So they say that the most growth happens at the edge of your ability, but I think there's also something to be said about linear growth as well. So the easy problems, I don't know. I think they're just working for me. It feels like I'm sharpening a smaller skill set of just searching a space in my head and seeing if I can come up with an answer. And now I feel like I have so many different methods I could use to check if I did a medium problem. But the goal would be, once I finish all the easy problems, that the medium problems are now remedial. But we'll see. So I'm going to stake the next year and a half on this, and hopefully it will exponentialize someone else's growth. So we shall see. And you should join the hyperbolic coding chamber and grab one of the cool new roles made by a very flaky piece of software I made called the Discord bot. So you should join the Discord bot, and you should join hyperbolic coding chamber, which is a vastly and quickly growing Discord chamber. That being said, the hyperbolic coding chamber necessitates that we complete LeetCode problems on entry. So we must pay our toll. And yes, the last 2 days we did some short sessions. I have a lot more time today, so we're just going to do the hour as usual, and I'm just going to jump into it. So this problem is categorized under C3 IoT. I have no idea what that means. Also, a fair bit of the easy problems, some of them are just padding. Like there was one we just had to add two numbers and return it. Given an integer array nums, return the largest perimeter. Given an integer array nums, return the largest perimeter of a triangle with a non-zero area. Perimeter of a triangle, you just add the lengths of the sides, formed from 3 of these lengths. It is impossible to form any triangle of a non-zero area. If it is impossible to form any triangle of a non-zero area, return 0. We must return the largest perimeter of a triangle, and if we can't create a positive one, we would return 0. So we're given an array of numbers. It's unknown how long the length will be. We need to make the largest perimeter, which I presume is what you just get by adding them all together. Or maybe you don't, because you get 0 here. I see. Maybe we're having to figure out how do you actually calculate the perimeter of a triangle. Maybe you get the perimeter of, never mind, I'm thinking of triangle. Well, triangles we don't know actually what type of triangle it is. I was assuming if we make it an isosceles triangle, then all the lengths would be the same. But I don't understand why we're returning 0 here. not a huge fan of these math problems. Let me see if I can. Why are they returning 0? Given an integer array nums, return the largest perimeter of a triangle with a non-zero area. Formed from 3 of these lengths. It is impossible to form any triangle with a non-zero area. Wait, return the largest perimeter of a triangle with a non-zero area. I just have to check how you make a perimeter of, yeah. Yeah, perimeter is A plus B plus C. They're saying you can just do base times height over 2. Math problems are so nutty. Turn the largest perimeter of a triangle with a non-zero area. This is strange. Given an integer array nums, return the largest perimeter of a triangle with a non-zero area. Formed from 3 of these lengths. Given an integer array nums, return the largest perimeter of a triangle. Perimeter of a triangle is a plus b plus c. I don't understand why these would be non-zero. If you could make any triangle here, if you could reuse the numbers, then you can make a perimeter of 3, 6. So why are they returning 0? If it is impossible to form any triangle of a non-zero area. Base times height over 2. Yeah, I just don't understand how they're getting 0 here. Perimeter is a plus b plus c. The area is base times height over 2. Okay, apparently I was just reading about how to do the perimeter of a triangle without knowing the height, and apparently you can get the area of a triangle, area of triangle with only lengths using Heron's formula. So we will never forget this formula, and it looks like the formula is the square root of s times s minus a, and s minus b times s minus c, where s is semi perimeter. I think we just have to calculate the largest area we can create. If it is impossible to form any triangle over if it is impossible to form any triangle of a non-zero area. If it is impossible to form any triangle if it is impossible to form any triangle well, let's plug it in. If we uncomment, or if we copy this, and we're just going to print what we get as the area, right? S is going to be equal to nums0 plus nums1 plus nums2 divided by 2. And A is going to be equal to num0 F, B, and C is going to be 1 and 2. Interesting. So I think I see what's oh no, wait. Yeah, our output, or S to the out was 0, which means that the area of this triangle 1, 2, 1 is actually garbage. Which means it's 0. So it looks like we can use herons. So maybe we'll create a function called herons. And it'll just take in A, B, and C, and it will return a number. We don't need A, B, and C here. We can just do A plus B plus C. And then we should just be able to do console.log herons. So hopefully that will work. We should need one more parenthesis. Wait a second. Our output is 0 for both of these. This heron's giving us 0. I guess another thing we can test is just passing in different numbers. If we get 0, something's up. Oh wait, I passed in. Okay, yeah, I passed in num sub 1 and num sub 1. It should have been num sub 0, 1, and 2. And then for case 2, we do get output of 0. So maybe we can just run herons to get the area of every triangle using only the lengths of the sides. It looks like what's implied is that you can't reuse sides. Because if you could, then the largest perimeter would be 6, because you could do 2 plus 2 plus 2 to give you 6. So this, you can definitely only use each number once. So, interesting. Interesting. Also, multiplication is commutative, I think, which means the order doesn't matter. So in the end, we pretty much want an array that has area. Well, no, we're just going to iterate through the numbers. We'll iterate through the numbers and produce an array of tuples for which we will sort. And while we're doing that, we'll only add it to the array. So we'll iterate through the numbers one by one, but -2. Basically, we want to iterate through all the numbers in the array -2 because we're going to be using 3 numbers at each point. And then at each point, I don't know if we'll catch all the possible numbers though, if there's more than 3 numbers. Maybe you could do this in n cubed time. That way you could check every possible combination. Maybe we'll do that so we can check every possible combination. And then from there, we'll generate the perimeters and the areas for all those. A tuple of perimeter and area, and then we can just sort by perimeter. So let me try and visualize it one last time. I have pretty much a cubed iteration. It's going to give us A, B, and C, which will pass to Herons. If the area is positive, if the area is non-zero, we'll add it to the array along with its perimeter. Then we'll sort it all by perimeter and return the first one, unless the array is empty, which will return 0. So I think we can do that. So do I is equal to 0, I is less than nums.length -2. Actually, no. Now we can just do the whole array since we're using cubed. So let me make this. We'll change this to J. We'll change this to K. I, J, 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 K, K, K. And then boom, we'll say that all the indices have to be unique. So if I does not equal J and J does not equal K, that means we should have different indices. there should be one more case. J does not equal K, and I does not equal K, I think is how it's supposed to go. I think this is the one. This is the way, but I'm not exactly certain. There's a way to do it so that you can shrink the number of, so you don't have to do each one against each one. But pretty much we'll say if herons num sub I, num sub j, and num sub k greater than 0, then we'll say tuples, which will be an array. It'll be an array of tuples we'll say, actually we just say if area is greater than 0, then from here we can just say tuples dot push, and we're going to be sorting by perimeter, so we'll just say num sub 0. I mean not num sub 0, num sub j plus num sub k plus nums sub I, comma area. Then here you can do tuples. We'll say if tuples dot length equals 0 or return 0. Otherwise, we're going to do tuples dot sort. We're going to have tuples here, so we're going to say we want to sort it by the perimeter in descending order. So we'll say b sub 0 minus b a sub 0. And then we can return tuples sub 0. Sub 0. Looks like we ran out of space. So on a really large array, we end up pushing too many onto actually, now I'm thinking we don't even have to sort. Can we just keep a running value of the largest area? The largest perimeter of a triangle that does have an area that's non-zero. So you could say max perim equals 0. And at the end, I think we could just return max perim doesn't really matter because the sort was n log n. And our for loops here was n cubed, so that was already worse. So not really changing a lot, but the space aspect can be fixed because then we don't need to keep track of all the tuples. We just need to know it has an area. And we can say parim is going to be equal to so say if it has an area and parim is greater than max parim, set max parim equal to parim. Okay, time limit exceeded. We got further though. N cubed I think is just too slow. I want to say we could turn the array into a pretty much distinctify the array, distinctify the numbers in the array, but it ruins cases where we could have like 23 times 23 or 23 plus 23 plus 23. Well, if it has the largest area, it probably has the largest perimeter. So what if we just did the opposite? What if we just did nums.sort AB? We'll sort it in a descending order. And then we can just do one for loop. And what we'll do instead could be like this. We don't need this line anymore since we're looking ahead. We do need this if statement though. Except instead of doing, we can just return max parim. I plus 1, we'll have I plus 2. Well, we actually don't need parim to be greater than max parim. We can just return parim. Nice. So that was cool. We got to learn about Heron's formula. That was cool. We don't need max parim. We don't need the console log. This one should be faster. So it's not the worst thing in the world. At a time complexity, we're doing a linear iteration of the numbers, but it's going to be overwhelmed by the sort, which is going to take n log n time. So I'd say it's n log n time. And we're not really using any space. So let's say n log n with constant space. No, did they just add the perimeters? No, there's no way we overthought this. Thought loss was... Side lengths of the triangle are A is less than or equal to B, less than or equal to C. Sufficient condition for these lengths to form a triangle of non-zero area is A plus B is greater than C. I see. Interesting. Well, I guess, yeah, we went for the math way using Heron's length because I didn't know that you could just, I didn't know how to tell just from the perimeter if something was non-zero area. So, guess you live and you learn some, so. Let's see what other problems we can do. So we have some more problems. We have find pivot index. Given an array of integers, nums, so we have an array of numbers, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index equal to the sum of all the numbers strictly to the index's right. If the index is on the left edge of the array, then the left sum. The index is on the left edge of the array, and the left sum is 0 because there are no elements to the... Turn the leftmost pivot index. I feel like I know the answer to this, but I don't really get the question. But I feel like it's just asking for the how you tell a pivot in a binary search. I think it's just left plus math dot floor, which is how we choose the leftmost index. Right minus left over 2. There's no left since left is 0, so we just say nums dot length. Or maybe not. Pivot index is 3. Left sum is equal to num sub 0. So it's num sub 1. Num sub 2 equals 11. Right sum is equal to 5 plus 6 plus 11. Wait, what? What is... I'm so confused. Given an array of integers nums, calculate the pivot index of this array. Pivot index is the index where the sum of all the numbers strictly to the the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. The index is on the left edge of the array. The index is on the left edge of the array. and the leftmost pivot index. Pivot index is 3, because if we add 1, oh, and including the number itself, we have 1, 7, 3, which is 11, and then okay, so you can just ignore the last number. We have pivot index is 3. We have left sum, which is equal to num sub 0, num sub 1, which is equal to 7. 1 plus 7 plus 3 gives you 11. Right sum is num sub 4, 5. It's just these two numbers, 6 and 5. How come they're not including the 6 here? Maybe you only have to it says is equal to the sum of all the numbers strictly to the indexes, right? Except they're excluding 6 here. Pivot index is 0. Left sum equals 0. No elements to the left of the index. Right sum is equal to num sub I plus num sub 2. Num sub 1 plus num sub 2, which equals 0. This question makes no sense, because in this example, they choose pivot index is 0, and we're excluding 2. Whereas in this problem, when the pivot index is this index 3, we end up including 3 in our sum. If the index is on the left edge of the array, pivot index given an array This problem is very strange. It has a lot of dislikes. Given an array of integers nums, calculate the pivot index of this array.
I don't understand.
I guess I'm having some transference issues. I'm keep thinking of this problem in terms of a binary search, and it's clear what I'm returning is not what you're supposed to return. You're supposed to return a pivot index, but they're not asking you to just do one part of the binary search pivot. So maybe a version we could do that would be n squared time would be to start at each index with 0, right? And they said like when you're at the left edge of the index and left sum is 0. So from there, we can just start at that index. And then go until the sums are the same. Actually, this makes it a little difficult because they don't have to be symmetrical. Because we don't have to say all three numbers here. Or at least in this one, it seems that you do. But pivot index is 0. But when you're going right, they only used indexes 4 and 5. They didn't use 6. But the problem explicitly states that is equal to the sum of all the numbers strictly to the indexes right. So that doesn't make any sense. I guess we could start at 0. And your sum will be 0 when you start. Or we could say, we could iterate through and we'll say if your index is either the left edge or the right edge, then the left sum is 0. But if the index is equal to the right edge, then the right sum is equal to 0. And then from there, we just keep adding numbers until the sum is the same. And if there's no way for us to do it, then we'll return -1. I think that would work. We'll say let I equal 0, I is less than. I'll stop the timer. I is less than nums.length. I plus plus. We'll have a left sum which is equal to 0. We'll say if, well, actually left sum does just start at 0. So we're probably fine there. Then we want to start at the index afterwards. So say m is equal to I plus 1. m is less than nums.length m plus plus, and then we'll say we'll have a right sum which we can set equal to 0 up here, and we'll say right sum will start at num sub I plus 1. Say if left sum equals right sum, then what they wanted us to return in the problem was the pivot index. That would be I. Then we can do right sum plus equal num sub it's a little bit messy. I think the right sum should probably just be 0. I'll say right sum plus equal num sub m. They're the same, we return I. Now, we'll change this a little bit. We'll say if m is equal to nums.length minus 1, then we'll set right sum equal to 0. Otherwise, we want to set it equal to right sum plus num sub m. So we started at 0. Right sum is equal to 0. So let m equals I plus 1. Left sum is equal to 0. If left sum equals right sum. Right sum is equal to right sum plus num sub m, which is 7. 0 is not equal to 7. It's not equal to 3, 6, 5, or 6. Then we go to... Wait a second. I'm not adding anything to left sum. If sum is equal to 0, I is equal to 0, I is less than nums.length, right sum is equal to 0. We go through the whole thing, right left sum never equals right sum. Then we do left sum plus equal num sub I, which is still 0. We do the same thing again. Except now I is equal to 1. My brain is fried. I feel like we could just figure this out if I just sat through here and read through. Oh, I see what's happening. Left sum and right sum are just equal to 0, so it just returns. I still think this should be I plus 1 though. I plus 1. I'm getting no output at all. Oh, I see. Case 3 is failing because Yeah, I'm pretty sure I just need to sit here and just look through the math of it. It's not really math, but just the numbers of it. Just kind of comb it through, and we'd figure it out. But I will say that for tomorrow.